All right, Space Vidcast fans, we're very fortunate to have Steve Levin here from JPL, and he is going to be doing a little bit of talking today about what's happening tomorrow. And I'm not going to say a word. Steve, tell me about Juno and the goodness we can expect to receive from it.
All right, well, we're launching tomorrow, of course. That's what's happening
Right.
tomorrow. Good Lord willing, and the river don't rise. And what we're trying to do, it's going to take 5 years to get out to Jupiter, but when Juno gets there, what we're trying to do is understand how Jupiter formed, because that tells us about how do solar systems form, how do planets form. So it tells us sort of about where we come from, how does all this stuff work. And Jupiter's the key to that, because it's so big, it's more than twice the mass of all the other planets in the solar system combined, and it probably formed first. So it's so big that it hasn't changed much. It formed first, so it influences everything else. If you kind of look at the solar system, if you looked at the solar system from a distance and you weren't like human-centric, what you'd see is the sun. And you'd say, pretty much that's it. Then if you look really closely, well, there's 0.5% of the mass or whatever that's in Jupiter. And then you'd have to look really closely to find the rest of the debris that makes up everything else, including us. So if you want to understand the solar system, you got to start with Jupiter.
Steve, you just called us debris.
Yeah, me too. That's the way it goes. Interesting debris.
But debris nonetheless.
But yeah, if you're making a solar system, basically you've made a star and the rest is just leftovers. Jupiter's the biggest piece by far of the leftovers. But we want to understand that process. We really want to know how do planets form, where did the water come from that makes the Earth and so forth. All that stuff that tells us about our origins, we can learn a lot about that from Jupiter. The tricky part is Jupiter, because it's so big and because it's covered with this enormous atmosphere, is hard to see inside. If you go look at Jupiter, what you're really seeing is the very tops of the clouds on this huge atmosphere. We want to understand what's below those clouds. We want to penetrate the clouds. Can't do that by just diving in with an object or a probe or whatever, because you can't get very far. The pressure's enormous. The temperatures are really high. Basically, nothing we could build could survive to go deeper than 20-ish times the pressure here on the Earth. And the middle of Jupiter, it's millions of times the pressure here on the Earth.